Here we're going to discuss what's called Descartes' rule of signs. So when you're factoring a polynomial, we're going to have different ways of doing that. And if this theorem here, or this rule of signs rather, tells us when we can sort of stop looking. Okay, so sometimes in our journey we say, oh, should I keep looking for certain zeros? And this rule tells us when we can stop looking. So what it does is it gives us the possible number of real zeros of a polynomial with real coefficients. So here's the rule of signs. We start off with a polynomial p with real coefficients, and there are two parts to the rule. The first part is this: the number of positive real zeros of p either is equal to the number of variations in sign in p, or is less than that by an even number. And I'll talk about what I mean by variations of sign in a moment. And part 2 says the number of negative real zeros is either equal to the number of variations in sign of p of negative x, or is less than that by an even number. Okay, let's see an example of this. Okay, so you use Descartes' rule of signs to determine the total possible number of real zeros of this polynomial. Okay, so I can see first of all this polynomial has real coefficients, right? The coefficients are all real numbers. So what you do is you first ask yourself with the polynomial, how many variations in sign are there? Now, all that we mean by that is how many sign changes occur between adjacent coefficients. So for example, the coefficient here is a 1, and the coefficient there is a 1 as well. So going from here to there, there's no change in sign because it's positive and positive. But when I go from here to there, it goes from positive to negative. This counts as one variation in sign, from positive to negative. Now what about from here to here? Well, that's negative to positive. That counts as a variation in sign as well. So there are two variations in sign, two sign changes. Okay. Now what Descartes' rule of signs says that it says that the number of positive real zeros, that is, when you look for real zeros, how many can you find? Either 2 or less than that by an even number. So if you subtract an even number from 2, the only possibility is 2 or either 0. So you either have 2 or 0 positive real zeros. Okay, and if I would have gotten 4 variations in sign, then my options would have been 4, 2, or 0. You're always subtracting an even number to get down to the next possible number of real zeros. In this case, 2 or 0 positive real zeros. Now, if you want to know how many negative real zeros you are, you don't look at p of x, you look at p of negative x. So you plug in negative x, and you get this. In the same polynomial, you get, let's see, negative x cubed plus negative x squared minus 4 times negative x plus 6, and that's equal to negative x cubed and then positive x squared, right? Because when you square negative, it's positive, and then plus 4x plus 6. So that is p of negative x. And the question is, how many variations in sign are there? Well, I go from a negative to a positive. There's 1. And that's it, right? Because it's all positive to positive from there on out. So I only have one variation in sign, one sign change between adjacent coefficients. And therefore, now again, it's either you subtract an even number if you can. Here you can't, right? Because 1 is an odd number. So it's simply one negative real zero. You're guaranteed to have one negative real zero. Over here, you don't know. It's either 2 or 0 positive real zeros. Here, because it's the number 1, you can't subtract 2 from it. Well, you can, but you're not going to get a positive number or 0. So you stick with the one that you have. If I would have gotten three variations in sign, my choices would have been 3 or 1 negative real zero. And if it was 5 variations in sign, my choices would have been 5, 3, or 1 negative real zero, or zeros. Okay, so put it all together, and what are our choices? We can either have 2 positive real zeros plus the 1 negative real zero, so we can either have a total of 3 zeros, real zeros, right? 2 positive and 1 negative, or we can have 0 positive real zeros plus the 1 negative real zero to get 1 real zero. Okay, so we don't know which it is, But Descartes' rule of signs says that, hey, you either have 3 real zeros or 1 real zero. And one of those is going to be negative, and either 2 positive or 0 positive zeros. Okay, and we're going to use this when we put things together for factoring polynomials generally. Okay, until next time.